starting chapter 2 today. Chapter 2 focuses on quadratics. So we are going to be graphing quadratic functions, and we are going to be talking about transformations specifically with quadratic functions. So we actually looked at a little bit of those last week. We are also going to describe the effects of changes in coefficients. And then I have those two equations there. The first one might not look very familiar, but that second one, y equals ax squared plus bx plus c, that is the standard form of a quadratic equation. Okay? How many of you remember using the quadratic formula in Algebra 1? A little bit. Okay. Don't worry, we're going to do that again this year. But that's probably where you remember picking out the a value, the b value, and the c value. So the a and b are coefficients. The c value is a constant. The a value can always be found in front of x squared. The b value can always be found in front of x. And then there's a little stipulation that we put on standard form. So standard form is that y equals ax squared plus bx plus c, but a can't be 0, because if a was 0, this whole term would go away. What type of function would I have left? I just had bx plus c. What type of function is that? What is it? Okay. Anybody tell me? Yeah. Yeah, it's just a linear function, right? Because it's x. Okay, and we focused a lot on linear functions in chapter 1. All right, so in example 1, we're graphing using a table. Before we start to actually graph, I just want to remind you what the quadratic looks like. So it either opens up and you have a vertex value that's the lowest point, or it opens down and you have a vertex level that's the highest point. And I put this dashed line down the middle. You guys maybe remember from geometry what that line might be? We learned something that's really early on in geometry. Have you guys heard the term symmetric? Okay, so that means if I were to fold it over that line, it would be the same. So that's what's great about parabolas, is one side should match the other side. Okay? So for example 1, we had f of x was equal to x squared minus 4x plus 3. So I want you to start thinking about, okay, if that's my function, what's my a value and what is my b value? And I did just say a and b. There's a reason for that. Has to do with step 1. In step 1, you're finding the x-coordinate of the vertex. You're always going to find that first. And the reason why you want to find the x-coordinate of the vertex is because the vertex is going to be the center of the graph. And we have this handy-dandy formula that can help us find it. The formula is x equals the opposite of b over 2a. So most of you already have that written down. And I wrote this reminder that it is the opposite because I don't want you to think it's always going to be negative. It's not. Okay? That negative means that you're going to be doing the opposite. Okay? So this is the opposite of your b value. So that's how I think of it. So when I'm looking at this and I'm using the formula, I like to look at my coefficients. Now, for x squared, I can't see a number in front, which means it's what? Yeah, it's going to be 1. If there was a negative, it would be negative 1. So my a value is 1. Okay, your b value, you have to take that negative there. So your b value is negative 4. And now we can apply that to our equation. So it's x equals, the opposite would be positive 4. 2 times a, 4 divided by 2 is going to give me 2. Okay, so this is x equals 2. Okay, so that's going to be the center of my parabola. Okay, and then actually what we can do is when we do this, when we create a table with 5 points, we're going to do 2 to the left and 2 to the right of the center value. So this is going to go in for x. That's going to go to the center. All right, now, if you know your x, how do you find the y value? Yeah. Yes.
You put in the x and then.
Yeah, you plug it in. You plug it into x for your equation, right? Okay, so to find the y coordinate of your vertex, you're going to substitute x equals 2 into the original equation. This somehow seems to be something that people forget, but it is one of the most useful things. Because if you don't know what a graph looks like, you can pick any value, plug it in, and create a point from that. So we're going to plug it into the original, f of x. Okay? It's really like your f of 2. So this is 2 squared minus 4 times 2 plus 3. It's just coming from this equation right here. And then you just evaluate. So 2 squared is going to be 4. Negative 4 times 2 is negative 8 plus 3. Okay, 4 minus 8 is negative 4. Negative 4 plus 3 is going to be negative 1. So your y value is negative 1. Okay, so then we can put that on our table. Okay, and I just like to label this as the vertex. And we are going to be talking about the parent function a lot today. You are going to create a table with 5 points every time. 5 points is perfect for the parabola, because remember for x squared, I think I have it on the board up there, right? When we graphed our parabola, we had 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So we have those 5 points. We're going to be looking at those a lot today. Okay, so that's why we're doing 5. All right, and then in order to create that table, all we're going to do is pick 2 to the left and 2 to the right of our center value. So we're just going to go up 2. So it would be 2, 3, 4. And we're going to go down 2, which would be 1, 0. The reason why you want to do this is because this is going to give you a symmetric graph. Okay? Do you have to pick those points? No, not necessarily, but you have to graph the parabola. And we want to see both sides of the parabola. Okay? All right, so now we're going to plug these in and find them. Now some of these, you can just use mental math, right? Because if you plug in 0, 0 squared minus 4 times 0 plus 3 is just going to be what? 3. Okay, sometimes I do partial mental math where I will do part of it in my head. So if I do 1 squared, I get 1. Negative 4 times 1 is negative 4, and then plus 3. And then that's easy for me to compute, right? 1 plus 3 is 4. 4 minus 4 is 0. All right, so I want you guys to compute 3 and 4. And then we can go ahead and we can graph that. And when you're graphing, I always start with my vertex. And then once you find it, go ahead and graph it. And make sure that you have that curve. It's a parabola, so it should be a curve. If you need to one side and then the other. All right, now what happened, what did you guys notice when you plugged these in? What did you get for 3? 0. What did you get for 4? 3. So see how these are symmetric? They should be. Okay, if you choose the center value and you do 2 to the left and 2 to the right, they should be symmetric. Okay, so I'm going to graph mine. I'm over to -1, 1, 0, 3, 0. 1, 2, 3. Just going to put my 3 here. -3, so we know what our scale is. Here's my 5. And then 1, 2. Okay, and then will you make sure that you have the arrows on each end? So this, it doesn't stop at these points. It's going to keep going, so we have to notate that as well. And then make sure that your table looks like this. I came around and checked, and you guys had what I had, which is great. That's what your table needs to look like. All right, let's do part B. So for part B, you have f of x equals -x squared minus 2. Okay, so I want you to do step 1, step 2, step 3. And if you don't remember, just look up here. Step 1, find the x coordinate of the vertex. So you're always going to be using that x equals the opposite of b over 2a. Okay, who can tell me where to find the a value? Where to find it? Yeah, get it?
In front of the x squared.
Yes, in front of the x squared. Okay, so Brianna, what value do we have in front of the x squared? Close. Yes, good. Okay, so your a value is -1. Okay, and then Rashawn, where do we find the b value? No, tell me where we find it. B is always in front of what value? No? Yes, in front of the x, okay? So our original function is y equals ax squared plus bx. So b is always in front of the x value, but there's no x value here. So in that case, our b would have to be what? What would you guys think? 0, yep. And then if we had to find c, our c value would be -2. Well, we don't have to find that for this. So when I plug this into my equation, the opposite of 0 is just 0. And then 2 times -1. I don't even have to do that. 0 divided by anything is going to be 0. Okay, so that's going to be my x value. And then I can find my y value just by plugging that into the function. Okay, so it's f of x equals, so y is f of 0. This would be -0 squared minus 2. Well, 0 squared is 0. If you apply the negative, it's still 0. 0 minus 2 is going to give you -2. So that's your y. And so your vertex is 0, -2. That's the center of your graph. And because it's the center of the graph, that's why we want it to be the center of our table. When you are constructing your table, you do have to have your x, y. Okay, so don't write these as points. In the directions here, it does say to graph by using a table, so we want to make sure that we are using that. like I said, a table is one of the most useful things you can do. You can always pick any x you want and find y. We're strategic about picking our values, so start with the vertex in the center. Now, we aren't always going to use the same values for x. It depends on the center. So if the center is 0, if I go 2 up, it's going to be 1, 2. If I go 2 down, it's negative 1, negative 2. Okay, and then sometimes I actually start with these, because I know if I do this right, it should be symmetric. So I'm going to deal with positives whenever I can. So this would be negative 1 squared minus 2. Make sure you're using your order of operations. So 1 squared is 1, negative 1 minus 2 is negative 3. We can do the same thing for 2. So you have to do the exponent first. So 2 squared is 4. Apply the negative. Negative 4 minus 2 is negative 6. Now it makes sense that we get the same thing for here. Sometimes I'll do this using mental math. I know negative 1 squared is still going to be positive 1. So it's still my negative 1 minus 2, which will give me negative 3. Same thing for negative 2. Negative 2 squared is 4, so negative 4 minus 2 is negative 6. And now I'm ready to graph. So this is a 10 by 10. Sorry, 0, 1, 2. You can also double check and look at this a value. Because it starts with a negative a value, oh, the graph should be opening down. What did I do wrong already? I plotted my first point wrong. What did I do? Yeah. Yeah, I put it in the positive. So I don't want to start there. I want to do 0, negative 2. There we go. And sometimes I'll label that point, or I'll label it a V. Then I have 1, 1, 2, 3, plus U. And then 2, 1, 2, 3, 4, 5, 6. And then again, we're connecting that with a curve. Like I said, sometimes I'll label that there, or I at least try to label something that shows my scale. 10, this is 10, here's my Y, here's my X. And again, make sure you have those arrows on it. And then we want a curve. Okay, we don't want like a hard V. Do you guys know what type of function, when you graph it, it looks like a V? Remember? The absolute value. I had time for that, now for one.